Alrighty guys, we're going to go over this problem on analyzing behavior around a vertical asymptote. I'm going to call this Math with Carlos because there's a 99% chance that he will bark during the making of this video. So we'll deal with it. Alright, so here's the first thing. We need to know where this function is discontinuous. So basically, look at the denominator. But not only do we have to know where it's discontinuous, we need to know what type of discontinuity it has, removable or non-removable. So to do that, the first step is always going to be to factor the top and factor the bottom, except in this case it's just x plus 3. So I'm going to quickly factor the top, and what you'll notice is nothing cancels. So what that means is the discontinuity in the bottom at x equals negative 3 is a vertical asymptote. So we know we have a vertical asymptote at x equals negative 3. Now that's old stuff. You guys already know that. What we're adding on right now, my computer's going to shut down. That's awesome. What we're adding on right now is we're trying to determine what happens on the left and the right of the vertical asymptote. So a couple of things could happen. We know that at vertical asymptotes that the graph can't cross the vertical asymptote. So the only choice the graph has is when it approaches the asymptote, it either has to go to positive infinity or it has to go to negative infinity. And our goal is to figure out from the right of negative 3 and from the left of negative 3, what's the graph doing? Is it going to positive infinity or is it going to negative infinity? Okay, so here's how you do that. You make what's called a sign chart. And this sign chart does not require you to plug in actual numbers. And I'll show you what I mean in a second. So you definitely don't need a calculator, okay? So watch what we're going to do. We're going to say that f of x is equal to, and I'm just recopying the function from the top so that we can write the things down here. So here's the function. And our question is, as x approaches negative 3 from the left, what is the graph doing? Okay, so when we plug in numbers in the numerator, you can actually go ahead and plug in negative 3 because you're going to get a value. So if I plug in negative 3 for x in the numerator, okay, it doesn't matter what you get. Like you get negative 1 times negative 2, but that doesn't matter. What matters is that it's a negative times a negative. So don't even evaluate it. Just say, okay, negative 3 plus 2 is a negative number. And then negative 3 plus 1 is another negative number. Here's why you don't actually care what the value is. Because you can't actually plug in negative 3 in the bottom because you'll get 0. And we know that anything divided by 0 is undefined. So what you do is you just think about what's happening down here. So we're going to say, all right, we're going to plug in a number that is more negative or to the left of negative 3. Now you can think negative 4 if you want, or you can think negative 3.5, but technically what we're plugging in is negative 3.00, literally an infinite number of zeros, and then a 1. Okay, so we're not really actually plugging in a real number. We're just kind of thinking about what would happen. So if we plug a number in that's smaller than negative 3, and we add 3 to that, we would get a negative number. And now you just use what you learned a long, long time ago about positives and negatives. A negative times a negative is a positive. We have a negative on the bottom. So the result is a negative. But negative what? So since we're approaching an asymptote, we know that the graph is going to go to negative infinity. So we can say as x approaches negative 3 from the left, the graph approaches negative infinity. Okay? Now let's try the next one. As x approaches negative 3 from the right, what does y approach? So basically, on the right-hand side of the vertical asymptote, does the graph go up towards infinity or down towards negative infinity? Okay, so here we go again. Again, plug negative 3 in up top. That's totally fine. So again, that doesn't change anything. Negative times a negative. Now in the denominator, you can't plug in negative 3 because you would get 0. We're going to plug in a number that is to the right of negative 3. So not as negative as negative 3. So something like negative 2.999 repeating forever, right? If we add 3 to that, you should see that you get a positive result. Well, a negative times a negative is a positive, and then a positive in the denominator is a positive. A positive divided by a positive is a positive, so that means that the graph is going to positive infinity. So here's what we know. To the right of the asymptote, the graph is going to positive infinity, and to the left of the asymptote, the graph is going to negative infinity. And I've been staring at this the whole time and wanted to do it. Make a little smiley face there. Yeah. Okay. So I'm going to do another one right after this and see if you guys understand that one too.